Good afternoon, everybody. Welcome to my talk. I'm Sreeram Kannan. I'm founder at EigenLayer and CEO at EigenLabs. Really excited to be here. In my previous life, I was a professor at the University of Washington, Seattle. This talk today is our vision. It's called Converting Cloud to Crypto. See the image here. I know some of you may recognize what's happening to the cloud. And that's what our goal is. So when you think about applications, you can think of applications in two dimensions. Applications need throughput, and the other dimension here is where you need to crypto. We think about how much value you're transacting per byte of transaction. So crypto applications today are not only low throughput, but high value. But to really get to powerful consumer applications, we need to look at the cloud. And cloud applications are high throughput and low value. Each byte is low value, but together they add up to a lot of value. And what we are looking at is how do we bring cloud applications to crypto? Converting cloud to crypto, that's our goal at EigenLayer. Why do we need to convert cloud to crypto? Crypto brings certain special properties. What are the properties? Crypto brings native incentives. You can program incentives into the structure of the application. It brings user governance. We say democracy is when the governed can govern. And in technologies, including social networks today, as a user, you have no governance rights. We want to bring governance rights back to users. And the third one is permissionless innovation. How do you ensure that anybody else can build on top of your products, your services in a rigid manner, enabling permissionless innovation? So these are the values that crypto brings. But today, cloud apps also need high throughput, and we need to be able to reduce the cost for byte of transaction. So, this is a perfect follow-up to Patrick's talk from Arbitrum. Rollups, we argue, are the perfect fit for consumer apps. Why do we say that? Rollups usually have a single sequencer. This sequencer can act to give instant confirmation, giving you the same UX that you're very used to when you're interacting with the server. Because, rollups have configurable execution engines, you can start building general purpose virtual machines, game engines, AI inference, all of these things natively on your rollups. You can start thinking about how to build applications without requiring necessarily crypto wallets. One of the main things that's happening today is when you're interacting with an application, you need to have a wallet. When you're interacting with a crypto application, you need to have a wallet. Why? You need a wallet because you need the wallet to pay the gas fees. What if you had a single sequencer, the sequencer can actually authenticate you in other ways? Already we are seeing the emergence of account abstraction, where users can be authenticated, not based on whether they have the fee or not, but based on whether they are a valid user inside your own system. And finally, when you build rollups, all of these rollups have composability with other rollups built on top of Ethereum. You can reuse the existing liquidity, but also reuse existing features built by other rollups from your own rollup. So all of these, I think, combine to create something really powerful in the rollup economy in Ethereum. But rollups do have some problems today. What are these problems? So the first one is throughput. If you're a crypto developer, one of the biggest things you worry about is, do I have enough block space? But nobody building on Amazon or Tencent worries about cloud space, because cloud space stretches to fit the demand. They will put more servers if you have more demand. The cost economics of rollups are also in jeopardy, because when you're thinking about a rollup, you actually face high uncertain costs. As opposed to if you're building on the cloud, you have guaranteed cost basis. You can reserve an instance, you know exactly how much it's going to cost, so you're building a much more reliable business. Security. You can try to compromise security and get these other properties, throughput and economics, but you lose the whole point of crypto. And finally, you want features. We mentioned different kind of execution environments. encryption, all these other features. And cloud comes with a massive array of software as a service tools that let you build applications without having to reinvent the wheel every time you need to use a new feature. I'm going to talk about how EigenLayer, on EigenLayer, we're building a new service called EigenDA, Eigen Data Availability. This is a mechanism to support rollups. When you're a rollup, what you're doing is you are moving execution and creating a mechanism to prove that you're executing the right thing to Ethereum. But you still need a place to publish the data. And that's what EigenDA does, is it creates a mechanism, a highly decentralized mechanism built on top of EigenLayer, which brings the trust network of Ethereum, portions of the Ethereum trust network, to actually support other applications. So the first, I'm not going to talk about how EigenDA works. That's going to be out of syllabus for today. I'm just going to talk about what features it actually offers. Throughput, the first feature. When you think about a data zone, you think about 3G, 4G, 5G, like your cell phone, the first thing you think about is what is the rate at which it runs, how many megabytes per second can it process. And that's the same metric you need to think about when you're thinking about a data availability system. EigenDA runs at 10 megabytes per second. But while running at 10 megabytes per second, it doesn't require, there are many mechanisms of scaling. One mechanism of scaling would be to say that every node that needs to participate in the network needs to have a really beefy, high-power machine with a huge amount of networking. But that's not how EigenDA is built. It's built with each node can have a small amount of bandwidth, but together, they're able to contribute the bandwidth to something much larger. And the principle is, this is why EigenDA is able to get orders of magnitude improvement over crypto scale today. And the reason is, in crypto today, decentralization works against scaling. If you want to make your system more decentralized, you have to make sure that the node requirements are small, which means you're not getting scale. In EigenDA, decentralization is scaling. Why? Because we are able to integrate the data bandwidth across all the different nodes so that the net performance of the system is the sum of all the bandwidths of all the nodes that participate. So our goal is to scale the throughput of data on EigenDA to gigabytes per second and one day even terabytes per second. So the next thing is economics. When you think about the economics of building a rollup, I'm now comparing it. Earlier, I compared it to the cloud. Now I'm comparing it to building a layer one. There are certain ways in which rollup economics is not really competitive with layer ones. The first one is the data costs. To write data to Ethereum, the costs are very high. Not only the costs are high, the costs are uncertain, because you'll be using your rollup, writing data to the common Ethereum data pipeline, and then what could happen is there is a new NFT drop somebody else is doing, another rollup is doing, and that interferes, that contests, that congests the common network that you're using. So DA cost becomes uncertain. Suddenly the price shoots up. And then the next thing is, unlike a layer one, a rollup takes exchange rate risk. What is the exchange rate risk I'm talking about? If you're a layer one, you fix a certain amount of inflation of your token to pay for validators. But rollups actually have to pay fees in a different token in an uncertain exchange rate. And finally, rollup tokens do not have any native utility in their system. Unlike if you're a layer one, your token's actually securing your network. So what happens with EigenDA is all of these change. How do they change? The first one is because we have plentiful data bandwidth, the cost is low. Not only the cost is low, we have a mechanism called long-term reservation. Just like you go to the cloud, you go to Amazon and you can reserve a certain instance just for running for you. You can actually reserve a certain amount of data bandwidth just for your rollup on EigenDA. This bandwidth is uncontested, uncongested. Nobody else can use it. It's only for you. And the next feature in EigenDA is you can pay for data availability in your own native token. You don't need to take an exchange rate risk. You can have a fixed fraction of inflation of your own token to actually pay for data availability. And finally, rollups can use their own token using EigenDA in what we call dual staking, where data availability is guaranteed not only by each stakers in the Ethereum Trust Network, but also by your own token holders and your own quorum. They participate in securing the data availability for your network. How does EigenDA bring all these features? Because it is an Ethereum-centric data availability system. So the way we think about it is, you look at Ethereum, there is a fundamental problem, which is there's a lot of rollups, but there's not enough data bandwidth. How do we actually build this? How do we bring the security of this as close as possible to Ethereum? You can never get exactly the same, because a natively integrated system is always better, but how do you approximate Ethereum security closer and closer? And EigenDA is built on several aspects of security. The first one is ETH staking. So Ethereum stakers stake ETH and participate in EigenLayer, and they commit to also participating in EigenDA, the data availability system. Operators in Ethereum are already decentralized. We can bring on board a lot of them into EigenDA and bring the decentralization back into the data availability system. And finally, I mentioned EigenDA supports dual staking, where you can use your own native token, your rollup token, to secure the data availability using the EigenDA software, but not only now running ETH staking, but also running your own token staking. So all of these tie together to ensure that the system is as secure as possible. Finally, when we think about features, I highlighted 4 problems earlier: throughput, cost, security, and features. What features are rollups missing today? Ethereum's data bandwidth is limited, and what you can do is, on EigenLayer, not only we have EigenDA, but there is a large ecosystem of services building on top of EigenLayer. The first example is EigenDA, and what that does is to scale the data bandwidth from 80 kilobytes per second in Ethereum to 10 megabytes per second on EigenDA. The next thing is the Ethereum finalization time. When you write a transaction into a rollup, it needs to be returned to Ethereum, and Ethereum needs to finalize. It takes 12 minutes for Ethereum to finalize a block. How can we get super fast settlement? Other layer ones have really fast settlement times. You can actually build a super fast settlement layer on top of EigenLayer. There are many coming up. We're working with Near Protocol, for example, on a super fast settlement layer, but there are many others as well which can actually do this. And you can bring finality time of your rollup to less than 1 second. Rollups rely on single central sequencer for ensuring censorship resistance. If you want to build decentralized sequencers, there are many protocols building different kinds of decentralized sequencer. AltLayer has a protocol called Restaked Rollup, which bundles several of these features and allows you to run decentralized sequencers. Espresso is building a shared sequencer where a common zone orders transactions across many, many rollups. Bridging. When you want to bridge it from one rollup to the other, you have latency problems. Each rollup needs to settle back to Ethereum. Arbitrum takes 7 days to settle back to Ethereum. And if you want to move an asset from one rollup to the other, it's going to take you 7 days. Can you actually do anything better? If you incorporate restaking, what you could do is, once a bridge has a measurable amount of economic security, let's say your bridge has $1 billion of economic security, it can let you mint and wrap assets worth $1 billion within that 1 week period. So what you get is you can actually get instant bridging across different rollups, where you can even move value and create new services on top of the rollup economy. MEV is a major problem. How do we do transaction ordering while managing MEV? There's a whole bunch of MEV services like threshold encryption coming up on EigenLayer, which can actually solve some of the problems. Finally, we talked about limitations and how EigenLayer can solve some of these limitations. But you can also add new features which never existed before. You can have new oracles secured by Ethereum staking. You can have transaction activation, you can have two-factor authentication, you can have trusted execution environments, fully homomorphic encryption, ZK-proof verification, AI co-processors, a whole host of really powerful services coming up on EigenLayer. When you integrate with EigenLayer, you can start consuming these services to provide a really rich ecosystem of services to your own rollup. With that, I conclude my speech. Thank you so much for listening.